let's talk about rate laws and how to write rate laws. So this first bit might not make a whole lot of sense, but once we practice these, you'll see it'll be like, oh, okay, I see what's going on here. Okay, so just stick it out. So when we write a rate law for a chemical reaction, we always write it just based on the reactants. The products do not go into a rate law. So maybe the first thing you want to write down here is don't put products into a rate law expression. We'll talk about what a rate law expression is here in a second. So make a note of that. No products in rate laws. No products in rate laws. No products in rate laws. Okay. How do we write a rate law? Well, the rate law is always written as the rate of a reaction equals some constant. This is called the rate constant or constant of proportionality times the concentration of each reactant, so the molarity of each reactant, raised to some exponent called the reaction order. Now we'll talk about how to get the reaction order. That's actually the rest of tonight. Really, is talking about the initial rates method for getting reaction orders. There's really only two ways to get the reaction orders. Both of them involve experimentation. These reaction orders can only be found by running an experiment, either an initial rates method experiment or a mechanistic study. Okay, but before we get into finding what these are, we first need to just practice writing rate laws. Now, I actually don't like to use an N. So some textbooks use an N, an M, and an O. The problem with O is O looks like 0, right? And one of the possible orders you could have would be 0. So I actually like to do X, Y, Z. So I actually like to have my orders as an X. So I recommend doing X, Y, and Z for your reaction orders. Let's talk about how to write these. So I'm not going to do the orders here yet. We're going to leave that. I want to just practice writing some rate laws here in general. So let me pop this on the board and we'll do this. So our first one is going to be N2 plus 3H2 goes to 2NH3. So I want to write the rate law for this reaction. So the first thing when you're writing rate law, the products don't matter. We do not include product concentrations in our rate laws. We base the rate of chemical reactions only on reactants when we're doing this rate law stuff. And what we would write is we would write rate equals some constant K times the concentration of each reactant. So times the concentration of N2, and that's going to be raised to some order. We're going to call it X. And then times the concentration of H2, and that's going to be raised to some order. We'll call that Y. Notice that the coefficients did not matter, right? I didn't care that there was a 1. I don't care that there's a 3. The coefficients don't matter here. Okay, when we're writing rate law expressions, these orders have to be found experimentally. You cannot use the coefficients. Now, once I know the rate, then I can compare the rates. But in terms of the rate law, the coefficients are not going to matter. Okay, let's have you practice one. So try, actually, what's you practice the next two? Try the second one and the third one here. Can you write the rate law for that decomposition reaction? And can you write the rate law for that synthesis reaction? Go ahead. Right. So the first thing, the products don't go into rate law expression. So I just cross out the products. So my rate law is going to be the rate of this reaction is going to be equal to some constant K times the concentration. I only have one reactant in this decomposition reaction. So times the concentration of KClO3, and then that's going to be raised to some order X. Again, in a moment, we're going to talk about how to get these orders. Hang in there. Then next up, it's going to be rate equals constant, the rate constant K. Again, products don't go in. We're going to have three things this time. So that's going to be the concentration of N2 to the X power. That's my first one. Next up is going to be the concentration of O2 to the Y power. And then the last one is going to be the concentration of H2O to the Z power. And you can put little time signs in there if you want.